Hello everyone, it's a pleasure meeting you all in my mathematics class. Today let me discuss problems in problems solving a partial differential equation which is a homogeneous equation with constant coefficients. See, for example, it will be of the form like this: f of d dash is equal to say some e to the power of x plus 1. This is a partial differential equation. That means this f of d dash means you will have the partial derivatives of maybe of nth order or any order for that matter with constant coefficients. See, the problem here it is given is this is d squared d dash squared of z is equal to, here also it is z. See, f of d dash f of d dash of z is equal to e to the power x. I have just given an example what is a partial differential equation, how to represent a partial differential equation in which d dash come and they can be of any order and it is equal to some function that is e to the power of x plus y or circular function or hyperbolic functions, anything. Here, for example, you take this problem, you will find that this is d square. D is nothing but our dou x, dou z by dou x. And d dash is dou z by dou y. So this is our understanding. And this on z operator is equal to so much. Now our job is to find what is our z. That is finding the solution to the problem. That means we should be able to get z in terms of its independent variables x and y. This is what we should do. These problems are similar to solving ordinary differential equations. When you solve the ordinary differential equation, you see that your solution will be y is equal to complementary function plus particular integral. So in here you see that this is an ordinary differential equation. You will have x and y is dependent function and x is an independent function. Now if you are asked to solve an ordinary differential equation, you must be able to solve for y, which will be in terms of x, and the solution is given by complementary function plus particular integral. If the given differential equation is a homogeneous, as I told you, homogeneous and having constant coefficients, let us take it in that way. So here you see that this will be given in the same way. Here we will give z is equal to what? Z is equal to complementary function plus particular integral I. So here again we should be able to get the function z in terms of, that is given z is equal to complementary function plus particular integral. The only difference is that here you will have two variables because z is depending on two different variables. Z is equal to z of x, y. So we should be able to get a solution only in this form. Now how to get that is a question. Now I'll step by step I will explain how this is done. Okay. Just we have to follow the same methodology as for ordinary differential, solving an ordinary differential equation. Now you see that this is d squared plus d dash squared of z is equal to so much. Now in ordinary differential equation we write the auxiliary equation. Now here the auxiliary equation is given by, take d is equal to m. We have to take d is equal to m and d dash is equal to 1. Take d is equal to m and d dash is equal to 1 and solve for m and write the complementary function. Now you take this d as m and d dash as 1. So you will get it as m squared plus 1 is equal to 0. That can be written as m plus I into a minus I, because m squared a plus b into a minus b is a squared minus b squared. So m squared plus I into minus I will be what? I squared. Minus into I squared is minus 1. So minus into minus 1 is plus 1. So you get this. So the factorization of this m squared plus 1 is equal to m plus I into m minus I, which is equal to 0. This implies that m is equal to plus or minus I. So we are able to get the roots of the auxiliary equation. Once the roots of the auxiliary equation are found, then we can write the complementary function. The complementary function is written as phi 1. You can, this is any function. You can write f or phi or psi, anything that you want. And this is phi 1 of y plus, one of the roots is plus I, therefore I write it as y plus ix. The other root is y minus ix, y minus ix. See, we have to follow the same principles as in ordinary differential equation. There, if you have two different roots, you see that we write it as a into e to the power of m1x plus b into e to the power of m2x. Same way I have written here. And all those things, other things are there, which I will tell when I do problems, and when I come across such situations, I will tell you how it should be done. But taking this problem, you must know that the auxiliary equation, that is the complementary function, is nothing but phi 1 into y plus ix plus phi 2 into y minus x. So this forms a part of the solution, namely the complementary function. Now coming to the second part. See, what is that particular integral? As we have done again and again, I am telling you that we will write it as, if you are going to, this is nothing but, see, in ordinary differential equation you will write it as y, see, complementary function, particular integral is equal to 1 by fd of this say function, say some, let us say that it is e to the power of x, something like this. You will go for this will be a function of x. See, here it will be a function of x, and you will integrate 1 by f of d. See, 1 by d f of d is nothing but integration. Try to understand. 1 by d is the inverse of that. So inverse of differentiation is your integration. So this is nothing but you are going to integrate it. Okay. Now, so in the same way, you see that this will be nothing but what? Here it will be your particular integral will be equal to 1 by f dd dash of e to the power of x plus 1. So this is your particular integral. So what I write here is, see, this is what I write. Particular integral is equal to 1 by your f of dd dash is what? Your f of dd dash is equal to d square plus d dash square. So this is what you have. So 1 by d square plus dd dash square is equal to into sine 2x plus sine 3x sine 3y plus 2 sine square x plus y. So I have to do the actually speaking integration I am going to do. Now, see, this is consisting of two particular integrals. This is one particular integral I have written here. The second particular integral is the second one. So I will do separately and tell you, and then we will join and get the final answer. Okay. So this is pi1 is 1 by d square plus d dash square of sine 2x sine 3y. Again I am telling you that follow the same principle as you go do the ordinary integration. Here this is going to be an ordinary, you are going to integrate it, but integrate with respect to x and y. So here you see that this is sine 2x sine 3y, but sine 2x sine 3y, I multiply it by, can you see this? I divide it by 2, so this is multiplied by 2. So you see that when you multiply it, I'll write it here. So your sine 3x, it is like this. See, 2 sine 3x sine 2x sine 3y is equal to cos of 2x minus 3y minus cos of 2x plus 3y. So I am bringing it to a sum form. Here this is in the product form, I will not be able to integrate. It is not possible for me to integrate. So I bring it to the sum form. See, this is the sum cos of cos A minus cos B. Something like that you have got. So you see that this you take it as what? Call this as your A, call this as your. So this is 2 sin A sin B. 2 sin A sin B is equal to cos of A minus B minus cos of A plus B. So I have used this. See, can you see this here? I multiply this by 2, divide it by 2. So 2 into this will be your cos. See, this is your cos. So that is what I have written here. See, this is what I have right here. Now, take this half outside. Now, when you are going to integrate this, that is 1 by d square plus d dash square of cos 2x plus 3y. What you have to do is, if you are going to do with respect to d means dou by dou x. dy means what? Dou by dou x. Dou z by dou x your d. And you are going to do the integration with respect to x and y. So when you do with respect to x, it will be cos 2x will be equal to what? Here you take it as cos of a plus b. If you are going to do here, if you are going to do it as d square plus d dash square, see, if you are going to differentiate this, it will be your d will be, see, your d square will be equal to minus a square and d dash square will also equal to minus b square. So you are going to replace this, see, replace this d square, that means you differentiate, you have to integrate square by minus 4 and replace this d dash squared by minus 9. So you get this. So I have written here, this will be your, if you are going to take this as your 2x, see, ax plus by. So this is cos of 2x plus 3y. So this will be minus 4 and this will be minus 9. This will be, because you must know that here it is 2x minus 3y, 2x minus cy. So it is 3x minus 3y. 2x minus 3y. So when you go for computing 1 by d square plus d dash squared of cos of 2x minus 3y, replace this d squared by minus 4 and d dash squared by minus 9. So I have done this here. See, it is minus 4 minus 9. When you come to this part, this is again, what is this? 1 by, see, 1 by d squared plus d dash squared of 2x plus 3y. See, except for this 2x minus 3y, and then here again, what you will do is, you will again replace it by d squared by minus 4 and d dash squared by minus 9. So what is that you will get here now? So when you replace it, it is minus 4 minus 9 into cos 2x minus 3y minus 1 by, again for this integration, it is minus 4 minus 9 into cos of 2x plus 3y. When you go for simplification, this is minus 13 cos of 2x minus 3y minus 1 by 13, it is be plus. So you see that this will be your plus, it will be your, here it is, yes, this will be, here it is, yeah, it is minus, and here it will become plus, and you take this, here also minus, so you take this minus, say it is minus 1 by minus 13 cos of 2x minus 1. This is plus, and so you take this minus sign outside. So minus 1 by 13 into cos 2x minus 3y minus, because minus into minus will make it as plus, cos 2x plus 3y. Now take this also outside. So I am taking this outside, but this is cos 2x minus 3y minus cos 2x plus 3y. Can you see this here? Cos 2x plus 3, see this one is nothing but your what? 2 sin 2x 3y. That's what I have written here. 2 sin 2x sin 3y. This 2 and 2 will go off, giving you with what? Minus 1 by 13 into sin 2x sin 3y. See here, I will explain once. I cannot do this 1 by d square plus d dash square on this sine 2x sine 3y. I multiply it and divide it by 2 and identify this 2 sine 2x to sine 3y in this form. Product form cannot be integrated. So what I do is I bring it to the sum form. So I am able to bring it to the sum form as cos 2x minus 3y minus of this. Substitute. So in this place you substitute here. In this place you substitute this. So I have substituted this. Then go for the integration of this. When you go for the integration of this, finding the particular integral, d squared must be replaced by minus 4. Whatever means, if it is a, minus a square. If it is b, it is minus b square. That's what I have done. So here it is minus 4 minus 9. For this also it is minus 4 minus 9. So on simplification, you will get this, but I am able to identify this as my 2 sine 2x sine 3y. I replace it and go for cancellation. So my PI1 is this. So I find the particular integral 1. Now let me come to particular integral 2. What is that particular integral 2? 1 by d square plus d dash square of 2 sine squared x plus 1. And this, I will write this identity here. Here again, this is in the product form. I cannot integrate. So what I do is I might bring it to the sum form. We know that, see, we know that cos 2x is equal to 1 minus 2 sine squared x. So this implies 2 sine squared x is equal to 1 minus cos 2x. So here, therefore, this implies 2 sine squared of x plus y is equal to 1 minus cos of 2 of x plus y, that is equal to 1 minus cos 2x plus 2. So this is what I have. See, this is what I have done here. So I have used this identity, namely cos 2x is equal to 1 minus 2 sine squared x. So in this place 2 sine squared x plus y. Hence instead of x you are having x plus y. So I replace, so I am able to get it as what? 1 minus cos 2x plus 2y. Here again you see that this is of the form 1 by d squared plus d dash squared of 1 minus 1 by d squared plus d dash squared of cos 2x plus 2y. You see here this cannot be, you cannot say, if you have it as e to the power of 0, this will become, you will get it as 0, which we will not allow, and it cannot be 0 also. So what I do is, I take this d squared outside, and when you take this d squared outside, so what happens is, d squared into 1 plus d dash squared divided by d squared of, this will be your 1. So this will be equal to 1 by d squared into 1 plus d dash squared by d squared of 1. So this will be equal to, so this 1 means differentiation of this will be 0, this will be 0. So I can give it up. So you do it 1 into 1. So this will be equal to your simply d squared of 1. That is equal to, because d squared means dou by dou x, dou by dou x. So if you are going to integrate this 1, then you see that this will give you x squared by 2. So I'll repeat this. So this is nothing but what? 1 divided by d squared plus d dash squared, which can be written as d squared into 1 plus d dash squared by d squared. And take it in the numerator, this will be minus 1. This will be minus 1. 1 plus d squared into 1 plus d dash squared divided by d squared over to the power minus 1. I will not, this higher powers can be omitted because this will be 1 d into any d or differentiation of a constant is 0, so you can very conveniently leave it. So this will be 1, minus 1 means 1 only. So this will be 1 by d squared, 1 by d squared of 1. But 1 by d squared means dou by dou x. You have to integrate 1 with twice. You have to integrate 1 twice. If you are going to integrate once, you will get x. If you are going to integrate second time, it will be like this. Integration of 1. See, 1 by d squared means integration of what? It is 1. So if you are going to integrate it once, it will be x. But if you are going to integrate it twice, it means that x squared by 2. That is why you get it as x squared by 2. Okay. So this is how we get this x squared by 2. And coming to this is having the same method here. Say here, how do you do this? When you do this, replace this d by what? Say d by, I have written here, d by minus a square, d squared by minus a square, d dash squared by minus b squared. Here you can see that here your a is 2. See, a is equal to 2 and b is equal to 2. And therefore, d squared you replace it by minus d squared, d dash squared by minus b squared. So here a is equal to 2 and b is equal to 2. So here d squared will be minus a squared, d dash squared will be equal to minus b squared. See, that is what I have done here. So it is 2x means minus 4 minus 4. So cos of 2x plus 2y. So this I have already explained to you how we are getting it. X squared by 2 plus this is minus 4 is minus 8, minus into minus is plus 1 by 8 into cos of 2x plus 2y. So I am able to get what is my pi2. What is my pi2? Now you know that pi, see what is my pi? Pi is equal to pi1 plus pi2. So my pi is equal to pi1 plus pi2. So what is the final answer that I must give? So your final answer will be equal to what? Your z is equal to complementary function plus pi. That is complementary function plus pi1 plus pi2, because I have got here. Am I correct? So you see that this z will be equal to your complementary function. Complementary function is nothing but what? Your complementary function is, here I have written here. Where is your complementary function? Phi 1 of y plus ix. Say I have written here solution to 1. That is nothing but 1 plus 3 plus 4 means this is complementary function